I'm going to start off with a question. So, by the raise your hands, who here find it a bit challenging to keep up with everything that's happening on the web and on JavaScript, CSS, HTML?
Yeah.
Me too. So things happen in really fast pace on the front end on this whole web world right now, right? There are like new technologies, new APIs, new design patterns, new way of doing things, new frameworks even coming every few months. So it's kind of tough to catch up with everything. So what I've done here, obviously not everything, but I've created a list of things that we can already do on the web right now. And hopefully these are the things that you can just pick up today from this talk and apply at your work tomorrow. We're going to go through CSS, HTML, JavaScript, and in the end, DevTools. I'm Prashant Palikhe. I work at a company called Frontend, and I have a project right now with Rabobank. So there's a lot of things to cover, so I'm just going to jump right in. We're going to start with CSS. I'm going to start talking about the support queries. Feature queries it's called, at support. It's a stage 4 candidate recommendation, has a pretty good browser support, 93%. What it allows you to do is, it allows you to do feature detection and progressive enhancement just using CSS. Up until this point, we use like a JavaScript library, sort of like, what was that called, Modernizer, to do these kind of things, right? But this allows you to do the same thing, similar things, just using CSS. The way it works, for example, if you want to use Flex for layout stuff, but you still support browsers that do not support Flex, then you can start laying out things with floats, for example, and then use this query to target the browser that actually supports display Flex, and then apply everything display Flex related in that curly braces, right? So when your user base actually shifts towards the browser that supports display Flex, you can just go ahead and remove the old code. So that's really awesome. You can also, it supports a bunch of operators. You can negate it, not operator. You can also use it to detect custom properties. I'm going to talk about custom properties a bit more in just a bit. You can also use and operators, or operators, and this kind of stuff. And if you want to do similar querying using JavaScript, there's JavaScript API as well. So you can do css.supports, display Flex, or any other fancy CSS stuff that you want to use. Just use the support queries. Put those things in there, and the browsers that actually don't support will just silently ignore it. And if the browser does not actually support, then they'll just ignore the whole code. There's no error, so you can progressively enhance your website, right? The next one is focus within. Stage 4, working candidate, working draft, 69% browser support. Well, what it does, let me just show you guys. We all know this one. Input focus, we saw like, okay, the user is focused on this input, so we show something in response, usually border, color, or something like that. Focus within does the same thing, but from the parent's perspective. If one of your children, or you yourself, is focused, then browser is going to apply this focus within selector to this parent. So you can make your forms, for example, a bit more accessible by not just highlighting the input, but highlighting an area. I got a small demo over here. So let's say you got a checkout form like this, and you input on it. Using the focus within, you can just highlight the entire area, right? So that makes your app just a tad bit more accessible. And the next one, font display, is a great one for performance. To understand what it does, I have to quickly go through how browsers do font. Font as in custom web fonts. We all use custom web fonts nowadays, right? So whenever we use font, what the browser does is it actually waits for around 3 seconds before actually displaying, for the font to come in. And up until that point, the browser won't display any text if that text uses a custom font. And 3 seconds later, it's going to say like, okay, it's taking too long, so I'm going to fall back to the fallback font. That is usually the system font. So some browsers, like Safari, actually waits indefinitely for the font. So if your user is in a really bad network, yeah, they're not gonna see any text, and that's not good. So we use JavaScript to get around this problem. What we do is we usually start off by using only system or web state fonts like Helvetica, Arial, sans serif, those kind of stuff. And then we use some kind of JavaScript library to wait and observe when the fonts get loaded. And when the fonts get loaded, we apply some kind of a class in the body or HTML And using that class, we actually use the font. So the browser is going to display the fallback font right away, so your text becomes visible right away. And then eventually, when the fonts get downloaded, the actual custom web font is going to be shown. So that's great. This font display CSS property allows you to do exactly that, but with one line of CSS. No JavaScript required, no JavaScript library required, no JavaScript class manipulation and all that. Just the way it works is you have a font face declaration like this, right? You're using a font, some font.WoW2. You just tell the browser, like, I want this font to be displayed in the way I just described, which we do with the JavaScript hack. So basically, the values that font display takes is swap is an important one. Swap behaves in a way that I just explained. Basically, it waits. It shows the fallback font right away, and it's when the actual font comes in, it's going to apply that font. That's how the swap works. And stage 4 candidate recommendation, 76% support. Basically, we all use SAS or LES or CSS preprocessors like that, right? Because it makes our lives a lot easier to tame this beast of the CSS, right? So we use things like mixins, functions, and whatnot, but most of the time what we use is the variables, right? And custom properties brings these variables in native CSS. The way it works is like you define, for example, variables with dash dash. So if everyone can see the code, by the way, like, is it clear?
No.
So,
Can you make it bigger?
I can try.
Or maybe
So how about this? Does this look better?
the background color?
Okay, so you define a variable with dash dash. So dash dash base color becomes a variable. And after that, you can start using that variable by using a var function. So it's sort of like what we do in SAS, but this is the CSS way of doing things. Now, the good thing about, so you define all your color palettes and all that, layouts and stuff at one place, and you use it everywhere. So it makes changing and refactoring things a lot easier, right? So the good thing about this is it embraces the cascade of the CSS. So it actually, you apply it on the root, it falls down all the way down to the last child in the page. And you can override it on any level. So, so what's the advantage of this compared to SAS and LES? We already have variables in SAS and LES. The best advantage of this one, in my opinion, is that you can manipulate these variables in runtime using JavaScript API. So you can do things like document, you can get the document element, style, set property, and you can get the reference to this variable and change it in runtime. So I got a tiny little demo over here that displays this. So I got a page here. So, and on the top right, I got a bunch of controls, 2 controls that changes the spacing and colors. So this page basically uses the CSS variable. So if I change it in one place, I just update the value using JavaScript, and everywhere it's just automatically updated. It's just change one variable, CSS variable, the whole page updates. So theming becomes super simple. Similar stuff with color. So I got color over here. I change the color, and everywhere it's updated. So you can use this kind of things easily to create themes on your application, right? Super useful. Let's go to object fit cover. We use background size cover, right? Like you got a div with a background image in there, but the background image is in a different aspect ratio compared to the aspect ratio of the div. So normally it gets stretched in a weird way. What do? You do background size cover. All of a sudden the image gets the proper aspect ratio. Everything looks great. All right. So object fit cover does exactly the same thing, but for images and videos. So I got a picture over here. This is Jake Archibald from Google. We all know him, right? Like, but if you don't know him, you may not realize, but in this picture, it's a little bit stretched. The width, he's not that lean. So the width is 200 pixels, the height is 250 pixels, so it's a little like this. So if you want to fix this aspect ratio, just apply object fit cover to this image, and then the aspect ratio of the image gets respected, basically. Okay, pointer events none. Pointer events none is the CSS property with which you can basically tell the browser to kill any kind of pointer events that could happen on any element. It's better to explain this with an example. You use this basically just like any other CSS, pointer events set to none. If you want to reset it, set it back to pointer events auto. But let me tell you what it does. So you got an application like this, right? It's got a menu that pops in from the left. And when the menu comes in, there's also this backdrop over here, right? That animates with opacity. Now, you want to animate the opacity because you cannot animate display. you're gonna animate visibility. So you want to animate the opacity, and also because opacity can be animated cheaper by the browser by leveraging GPU. But for you to be able to animate opacity, the element needs to be on the page, right? And this is a huge backdrop that lies pretty much on top of everything else. So if this backdrop was present on the DOM, I cannot click on the menu anymore, right? Like, because I'm clicking on this backdrop, which is opacity 0 right now. Everybody with me?
Yeah.
Okay, cool. So what do? We want to hijack this. We want to tell the browser like, hey, I'm here. This element is here, but when I click on it, just act like it's not even there. That's exactly what we want to do, right? So apply the pointer events none to this backdrop. Now you can easily click on the element and everything works well. So you can transition, animate this opacity. So useful CSS property. The last one on the CSS I got is will change transform. This is a very powerful CSS thing, but it can be kind of tricky as well. I'll explain with some examples here. So the same setup over here. So we were animating this menu. The menu is coming in from the left. We are also animating the backdrop, right? Whenever things are animating, we hear this, hey, use opacity, use transform, because GPU, right? That's high performance stuff. But there's a little bit of missing stuff. Just because you are transitioning opacity does not mean that browser will be able to efficiently use GPU for the animation. We have to understand the browser's rendering approach a little bit. Basically what happens is like whenever things are animating, what we want to do is like if a browser paints your web page into one bitmap, that gets uploaded to the GPU as texture, and that eventually gets shown on the screen. When things are animating, what we want to do is every animating layer, we want to put those in a separate layer of its own. So this backdrop needs to be in a layer of its own. The page itself needs to be in a layer of its own, and then what browser can do is upload these layers separately to the GPU. And whenever you're transitioning opacity, animating opacity and transform, instead of getting back to the browser's main thread, browser can just tell the GPU to actually do the transformations, to actually make changes on the opacity values, that kind of stuff. So not only just opacity and transforms, the important thing is layers. You need to be able to you need to promote this animating element into a layer of its own to be able to tell the browser to efficiently leverage GPU. How do you do that? We could also do something like transform translate Z0 that does the same thing, that tells the browser like, hey, bring this element into a layer of its own. But the proper way to do that is will change transform. Not just will change transform. If you're changing opacity, you can also do will change opacity. Now let me just show you the example of this using the DevTools. DevTools got this really awesome rendering panel over here. Just stop me if things are not visible or something like that.
Can you make it bigger?
Sure. Is that good?
Perfect.
Okay. So paint flashing in this rendering panel is a nice one. So what does this do? Whenever you turn it on, if the browser is painting while doing animation, it's going to show it with this bright green flash. Is that visible?
Can you put it on the light version?
Yes. Okay, so we got paint flashing over here, right? Then things are animating, and the browser shows this like flash of green, as you can see. That means the browser needs to paint this thing while it's animating this menu. Painting is an expensive thing, and it happens on the main thread of the browser. You usually want to avoid that. Whenever you're animating stuff, you just want to leverage the GPU. So what you want to do is you want to use this will change transform on the things that are animating. So you want to put it on this menu that comes from the left. You want to put it on the backdrop that's also animating with this opacity. That means browser will then put them on the layer of its own, and as a result, what happens is, so if once you do those changes and you animate things, you won't see any kind of paint flashing, right? So this is a way to guarantee that your changes are actually applied and the browser is animating your stuff cheaply. All right? So that's what I have for CSS. I'm going to kill this right now. And we're going to move on to HTML. I got a bunch of stuff. I got three attributes that I want to talk about while describing this HTML thing, but I'm running sort of short in time, so I'm going to just keep it to 1, which is rel equals no opener. Okay, so we've all done this stuff, right? Anchor that opens a link with target blank, right? I guess. So is that a bit better? Anchor with some link, target blank. That's really not visible.
Select it. That's better.
That's better? So just anchor with target blank, right? One thing that happens when we do this kind of stuff is, let's say 1.com has a link to 2.com with target blank. When we do this and 2.com gets opened in a new tab, 2.com gets access to 1.com's window object via window.opener. Now, browser's cross-origin policy kind of does not allow the 2.com to manipulate the 1.com or access document cookies or whatnot, but 2.com can change the location, change the URL of 1.com. So you could do something like, I went from Facebook with a target blank to a new page, and from that page I can change the Facebook's link to something that looks like Facebook, but it's mine, and that has a, hey, you're logged out, please log in form. So the user's gonna put username and password again, and I get that username and password. It's kind of underestimated vulnerability, I think. Like, not many people know that, but it can be abused quite horribly. But very simple way to fix this is drop in this rel no opener in the target blank, and then we don't have window.opener at all, and everything is fixed. So that's, I'm going to keep HTML to that part for now. So we're going to go move on to nicer stuff, JavaScript and DevTools. JavaScript side, bind once is the new feature that I want to talk about. We all need to do event listening where we just listen to the event once and we're done with it, right? Normally we do it in this way, like element, add event listener, click event, you pass a callback. And when the callback is called, we're going to select element, remove event listener with click and the there? Oh. Okay, so we remove the event listener when the callback is eventually called, right? And that's the proper way to do it. That's a hygienic way of doing things. But now we have a newer way. The third parameter, false, which usually indicates the capture phase of the event. It also supports now objects. So you can say like browser, tell the browser like once true. That means the browser's gonna bind the listener to this event only once and dispose it automatically. So you can go ahead and remove this element, the remove event listener part of the code. The next one I want to talk about is intersection observer. Intersection observer is an API to detect when element enters the viewport or any containing element. So if there's a scrollable div, you can also detect when things come in, scrolls into this div. So that can be very powerful. For example, lazy loading comes into mind, right? So now, good thing about intersection observer is that we can really simplify code. Normally, what we do for lazy loading, we drop in a library, third-party JavaScript library, and it usually does all kinds of like get bounding client rect, listen to the scroll events, all these jank-inducing stuff. Intersection observer, browser's internal machinery, browser's internal API. Browser will tell you when element comes into the viewport. You simply respond to it. So let me just show you how you could implement lazy loading using intersection observer. You first of all, oh, this is going to be challenging. You first of all create a new instance of intersection observer, and then you pass that observer a callback. That callback gets called whenever observer detects that whatever you're observing comes inside the viewport. So there's a callback. So what do we want to observe? We want to observe images, right? So what I'm going to do is I'm going to grab all the images with the lazy class in it using document query selector all .lazy. That's going to give me a node list of all the image with lazy class in it, well, everything with lazy class in it. And I'm going to convert that into array using the spread operator. So now I'm going to loop through all these images, and for each image, I'm going to observe it with observer, with the intersection observer. Now, whenever these images come inside the viewport, this callback gets fired. So what do I do now? whenever this callback gets fired, I'm just going to swap this data source that I had with the actual image source to the actual source of the image. And that's it for lazy loading of the image. And in the end, I just unobserve the image because we don't care about it anymore, right? So just do observer.unobserve the image element. And that's it. That's the simple bit of code. So you get two benefits. You get simple code, simplified code, and you also get performance. So that's a newer API, super easy to feature detect and use it only for the browsers that actually support this feature. So next thing I want to talk about is request idle callback. Request idle callback is an API that allows you to do stuff during idle time. But what is idle time, right? To understand idle time, we need to understand a little bit about what the browser is doing in its main thread. Okay? So most of the browsers right now, they have main thread. Main thread is where your JavaScript runs. Main thread is where the layout happens, recalc style happens, all kinds of stuff happens. And the browser also, most of the browsers also got a separate thread called compositor thread. The images that I talked about, that layer gets converted into an image of its own, these are handled by compositor thread. Compositor thread issues graphics layer command to the GPU so that the main thread can stay less busy. So basically what happens, there's this vsync event, which is coming from the operating system. It's an operating system's way of telling the browser to start generating a frame. So the vsync event comes to the main thread of the browser. The browser is going to handle your JavaScript input listeners. It's going to do request animation frame callbacks. It's going to do recalc styles if necessary, layout stuff. It's going to do some painting and compositing. And when it's ready to ship the frame. So it's going to go ahead and ship the frame, right? And vsync event is the event that gets synced up with the refresh rate of the screen. Most of the time it's 60 hertz, so it's refreshing 60 times a second. So that means that you need to generate a frame 60 times per second. So if the browser was able to do all this work within this 60 frames per second budget, which means 60 millisecond time frame, and it still has some time left to do, that's where the request idle callback gets called. So it's truly the time when the main thread of the browser is absolutely idle. You cannot shim this, you cannot polyfill this, right? It's the browser's internal machinery telling you when the thing is absolutely idle. So, like I said, this is where the request idle callback gets called. So you can do some cool stuff at this idle time. An example, let's say you use it this way. You do window.request idle callback, easy to feature detect again, right? And you pass it a callback, and let's say you need to send some logs. So this logs get sent when the browser and the user is doing nothing with your application. But what if this send logs is itself like hogging the CPU, right? Then bad things can happen on main thread again. Browser's got you covered. So what it does is this callback receives a deadline object. This object has a method called time remaining. And if you call that method, it's going to tell you how much time is remaining before the browser needs to do the important stuff of creating a frame. So based on that, you could chunk your work into smaller pieces and do it on each idle time. So what I've done here, logs is an array, so I just pop the first one on the stack, send that log out. Then I'm going to say like, hey, are there more logs? Then I'm going to do it on the next request idle callback invocation. So with that, you can do smart stuff, right? Like if there are some preparation works that you need to do for JavaScript or eagerly load resources, then you can use this thing, request idle callback, to do this without affecting the users. So that's request idle callback. I don't have much time. I wanted to talk about the orientation, but I think I will switch to the DevTools because I got 5 minutes left. DevTools. I'm going to start on DevTools by telling you guys how to stay on the bleeding edge of DevTools, because DevTools update really fast as well. And there are like so many awesome features that so many developers are not aware of. But if they're aware of those things, you can be so highly productive while debugging stuff like Remy showed. So how do you stay on the bleeding edge of things on DevTools? First of all, you got to use Chrome Canary. If you use Chrome Canary, that's a nightly build. That means things get updated really fast. All the new features you can use as it drops into the Canary channel. And once you do that, you got to make sure that Developer Tools Experiment is turned on. So you have to go to this URL Chrome flags. So just over here and look for Developer Tools Experiment over here and make sure it's turned on. Once you have this turned on and you go to your DevTools settings, you will get this experiment panel. We already saw this one in Remy's talk. But cool thing, you can get more cutting edge than this. If you want to use like super pressed features on the DevTools, what you got to do is hit the shift 6 times. So on this page, just go ahead 1, 2, 3, 4, 5, 6, and there are other features. These are like super cutting edge features. They're like being worked on right now. So it may not be highly stable, but I use a lot of features. Like some of the things that I've checked here are being worked on, but I can already test it out and take advantage of it. So I'm going to show you some of these features later, but that's going to bring you to the cutting edge of the cutting edge. That's one way to do it. And with that, I'm going to move on to showing some of the things that I like in the DevTools. An example, the network panel. So I've got this tiny Angular 2 Hacker News client, right? So it's making some requests, and let's say you made some XHR requests, and you want to test out like what would happen if one of these requests failed, right? You can go ahead and change your backend or talk to the backend developers and say like, hey, change this for a while so that it throws 400 or 500 or something, or use some proxy. But you can do what you can do on DevTools, right-click on it, say block request URL, right? And DevTools gonna completely block this request URL from next point on. So if I go to show another tab and go back to the previous tab, this request that I blocked never reached the server, and then we can simulate the situation when some of your resources fail loading, right? You could try that with your CSS. You could try that with your fonts and see where the single point of failure may lie in your application. The next thing on the network, block URLs, next thing is replaying XHRs. So we have this XHR request going on, and let's imagine you are working on a new feature. It has a model, and there's a form in it, and you fill in the form, and in the end you submit, and an XHR request goes out to the server. And you are experimenting with this server endpoint. So you want to try it out with different values. And you're changing stuff in the backend, but you don't want to go through this entire interaction every single time you change something on the backend, right? Open the model, fill in the form, submit. What if you could just replay that request? You can easily do that. Right-click on this one. Let's go to a page where I can actually do this. So let's find a request. Right-click, replay XHR. So the browser's DevTools is going to fire out the XHR with the exact same cookies, exact same request headers. Basically, replay the previous XHR. So that means you can just change stuff in the back end, replay the XHR on the front end, and you're all set. I think that's all in network. Oh yeah, no, this is a good one. This is super fresh. This is one of those 6-shift super experimental stuff. And I absolutely love it. I use this thing called Charles, which is a debugging proxy. It's extremely vital for my day-to-day usage, day-to-day debugging stuff. But now, what it does, it's a man in the middle, basically. Like you make a request, you can say Charles is the application that captures it, and you can send whatever response you want back to the browser. DevTools has the same feature now, and it's called overwrite. You go to the sources panel. Let's go to Twitter. You go to the sources panel, and over here you have this new overwrites pane. So there's a set of overwrites. Click that set of overwrites, create a new folder, just whatever. Select it, and it's going to ask for the permission. Give it the permission. Now you have set up the folder where Chrome is going to put whatever it will be overwriting. So go back to the network panel, reload. So I'm going to find the HTML, and over here I'm going to say save for overwrites. Okay? Save for overwrites, and now this page, I can just edit it. So let's find a followers count, 360, because I want more followers. So I'm just going to change it to 50K, which brings me just 1K more than Remy Shark over here. So, and reload the page. And you see, over here. So that means the DevTools is just taking this one. It never hits your server. It's just gonna, you can modify the source code, in production, change the source code, and it gets applied to the browser. I mean, empty cache and hard reload, it still stays the same, so still 50K. So, but not just HTML. You can do this, the power is that you can do this with JavaScript. You can do this with CSS, right? So let's say you got you need to modify. You're working on a production application, and you need to debug some bug in some JavaScript code. Just go ahead, set up an override for that JavaScript file, change the code, save it, reload, and that code is actually going to apply. So you don't have to. That means that you don't actually, dropping the console log is super easy as well. You just go into the code and actually change the code, reload it, and browser's gonna take that code. I find this extremely useful. It's called network overrides on the Canary channel right now. So the next one I want to talk about is a bunch of stuff in the editor. So, like Remy said, this code editor in source code, sources panel. Let's find some source. JavaScript. Open sources panel. So basically what I want to show you guys here is like if you guys are using like a smart IDs like Sublime, Atom or whatnot, you can do a bunch of things to be super productive like multi-carrots and select the next occurrences and all that stuff. Those things, real quick, those things are available on the DevTools code editor as well. So you can basically hold command and you can have multi-cursor stuff, change code multiple times, like at the same time in multiple places. You can just grab, for example, one occurrence and hit Command D to find all the next occurrences of that specific word, and then multi-cursors are all set up for you right away. This kind of things. You can also do colon selection, hold option, and then you can do colon selection, multi-cursor again, this kind of stuff. So those are there, kind of makes you efficient while using DevTools. The next thing is debugger. I'm not going to go deep into the debugger, but I want to show you guys like 2 tricks that I use while debugging stuff. Or maybe just one, because there's not enough time. Let's say you are on this, like this, you want to debug this element that's hovering, that appears while hovering, right? So this like button. So how do you do that? You right click on it, inspect, and it's gone, right? So how do you get hold of this element that appears while hovering? The way I do it is I go to sources panel, and then as it's hovering, I hit Command F8 to pause the script execution. We've seen this with debugger, right? But you can do it anywhere. It's paused, and this element is still here. So I can go ahead and inspect it, and actually change the values. So that's like my workaround to sort of freeze the UI at any time, so I can debug style sheets. I'm going to keep it there. And there are console APIs, real quick. You can do stuff like, for example, if you have selected this element, you can do $0, and that's the reference to that element. You don't need to like do document query selector, ID of that element, or whatnot. Just $0 is the shortcut to the currently selected element in the panel. You can even get the event listeners assigned to this specific element. So let's say I got a button down here called more. There's got to be an event listener here. So what I'm going to do is I'm going to hit get event listeners, passing the $0, the element reference. It's going to give me an object. It says like, okay, it's got a click event handler. So let's go ahead and grab it. Dot click. It's an array, so I'm going to grab the first one. And there we go. Dot listener is the actual reference to the function, right? So, I just evaluated this expression, right? Get event listener 0, blah, blah, blah. It gave me a result. I have a shortcut to grab this result that I evaluated just now. $_ is the same value. So what I can do now, another thing is like, let's say, I don't know where this is in the source code, but I want the code to stop execution every time it hits this method. Go ahead and type in debug, passing the reference to this function, which I now have in $_, right? And then every time I click it, DevTools is automatically going to pause on this function. So we are basically telling like, hey DevTools, if this function is being invoked, just go ahead and pause it so I can debug things. So these are these nifty little tricks that I use on the console panel to do some quick debugging. What else do I have? Node.js debugging. So how many of you guys use Node here? Webpack? So whenever we're using Webpack, we're sort of using Node as well, right? But let's say we rely on the Webpack guys or the people on the interwebs to give us knowledge whenever we run into problems. But what if we could just debug this Node.js application ourselves? The way I do it is, go to iTerm, let me go to one of my projects that I use Webpack for. Okay. So now what I can do is Node.
Prashant's using.
Are we there? So the command, can we read this? So normally you read, normally you,
Only the telescope.
okay, this is this readable on the back?
Yeah, yeah.
I'll read it out. So normally you do like node and your script, right? What you can do now is node dash dash inspect dash dash debug rec and then pass your script. So I'm trying to debug Webpack here. So I'm gonna do user local /bin /webpack because that's where my Webpack is, and I'm gonna hit enter. So it's gonna give me this weird looking DevTools URL. Let's go back to the browser, fire up the DevTools. You see this green icon over here, the node icon? That means we can actually start debugging this node process. So what it's going to do is that debug break command is actually to pause the debugger as soon as it starts executing Webpack code. Now go through the Webpack code, understand what it's doing, debug it, find out why the Webpack compilation transpilation is not happening the way you wanted it to. That's Node.js debugging, and whenever you stop the node process on the terminal and restart it, DevTools automatically knows to connect these two up, so you don't have to click this button anymore, it will fire it up immediately. So I think I'm almost there in the last one. The last one is real-time monitoring.
Really?
So what does real-time monitoring do? It's basically the same thing as profiling what we see, or you want to keep an eye on memory, you want to keep an eye on DOM nodes, you want to keep an eye on rendering performance. You can do all of these things in real time. The way you do it is go over here on this panel, there are lots of hidden treasures here, and find this performance monitor. Right? Once you do that, you see this graph of stuff happening, like I currently have DOM nodes selected, so it's keeping real-time track of all the DOM nodes. It's keeping real-time track of JS event listeners, if size, CPU usage, and all that, but there are a bunch of other stuff you can do. So let's go ahead and add some more elements. So I went to the next page. We added DOM nodes so we can see it increase, right? So to keep an eye on things, what I usually do, I go to performance panel because we got this nice garbage collector here. Hit the garbage collection, everything should drop down, and just keep an eye on the trend, on the real time. Like you do something in your application, hit the garbage collector, and see if things come back to normal. If the DOM nodes get removed from the memory, if the JS each size gets back to the normal, all these things like that. So you can watch those things as you do stuff in your application. So that's basically it for DevTools. And that brings me to the end. And last time I gave this talk, and I went to Google Translate. Somebody shared it on Twitter. But what they did was they converted CSS in English to Latin, and it came back HTML. So that was really weird, but I wanted to share it as like, wait, what the hell? I thought it was really weird. I wanted to end on that note. That's it. Thanks a lot, guys.